Hey guys, it's Vince. Today in this video, we are going to be covering the process of creating the servicing graphics for the system as well as applying them to the system, and we'll do the continuation of actually going through and testing the system. But before we do, something I was emailed caught my interest, and I believe it will certainly catch many of yours. YouTube contacted me and said, "Hi, Corvette Guy 50, we're inviting you to pilot a new YouTube feature that allows you to add helpful notes to videos. These notes will provide additional information and create a better informed YouTube community." How this works: when you find a video that might be confusing or inaccurate, you can submit a note clarifying it. Your contributions will be reviewed by others with a wide range of views to ensure their quality and helpfulness before being added to the information panel below the video. Together we can make YouTube even more helpful for everyone. Now, I want you to think about what I just read here and what you're reading, and think about what we've seen with my fail video series, because it is directly correlated to what we're seeing here. And I think it is going to make the network a much more trustworthy source as this is done. And you can see here they actually have a viewer's added note, and they're just showing you what it will look like. Now, of course, it says down here, please note that this experience is currently only available on mobile devices. You may be placed on the wait list for access to the pilot. You will receive more information when you're off the wait list and able to write the notes. So again, they're definitely revising the system. I think this is a great step forward. I think many of you are going to enjoy this because, again, you won't have to worry about spotting the knot as much. They will naturally help vet some of the information that's being placed on YouTube now, because once again, we're seeing channels pop up everywhere. AI is popping up everywhere. And as we've seen before, everybody's an expert until they're basically told they're not. So this is where things are going to really get interesting. And I don't know how YouTube is actually sending these messages out, if it's being done to everybody. I don't know. But like I said, I think for the future, it's definitely going to make the algorithm more prone towards vetting the information that's being, once again, placed online. So that's definitely the right step forward. So let's go into Vinyl Master, and let's have a look at what I've designed. Now, Vinyl Master is my vinyl creation software, and again, doing this as far as creating controllers, one of the things I wanted to invest with right away was vinyl software, along with the equipment to produce the vinyl, because of the simple fact that it takes the knowledge that I have and it allows me to place it on a system for my end users to use. Now, I want you to think about that, because I can tell you right now in this industry, it's very seldom done. Number one, they don't want to spend the time to do it. Number two, they usually don't want to do it because they know that it's limiting their ability to charge you for support. Now, that being said, these are basic diagrams for what every end user will need. This will actually mitigate excessive amounts of support required, because you'll have the information on the controller for you to access your system. You can see here we've got port 1, and this is for all of the switches, and then we have the pin allocation in Mach 3 for all of our 4 switches. Okay, and you can see here I even put the wiring diagram on here. I can tell you right now, like many of you already know, there are no vendors that do that. Vendors typically do not want you working on your system because they want to make it proprietary. Totally understandable if I was to do that, because again, basically what I'm saying is you're going to contact me to service your system. But see, I'm more realistic in an open source world that, number one, it doesn't behoove me to have you have me work on your system when you'd have to mail it back. It's going to cost you more money, more downtime. You'd actually lose more clients that way. You're much better off servicing your own system, pending, of course, you're comfortable. I do have clients send back their systems, but I want to give you guys the option to do it. Now, if you're uncomfortable, and I'll say that again, you should, of course, contact me or whatever vendor you've purchased from to send your system back for servicing. That's the correct thing to do. However, having these diagrams, and once again, I mean, it goes down to actually having the digital realistic image of the switches. along with the motor's digital image, and again, the step and direction signals for the motors. This keeps things as simple as possible. You can see here how we have the color allocation to the text, which represents the wiring that is done to the GX16 5-pin. So we also have, and just think about how much time it takes to create these graphics, guys. I really want you to think about it as we go through this, because again, there's a reason a lot of vendors do not do it, because of the amount of time also required to do this. You can see here we do have another graphic that will be put on the front of the system, meaning the front panel, so that as you guys go through, you will not need a manual. You'll be able to program in your settings and you're good to go. You can see I even have a note down here for our spindle relay 1, because each drive is different, of course. And on the SMCU, there are caveats when you use or don't use the charge pump, because again, there's a limitation on the number of outputs that the parallel port will support. So again, that's here. You can see where your e-stop is, all of your switches. Basically, everything you need is right here. Now, as we scroll down, and again, what you're looking at, just so everyone is aware, the border you see on the black, this represents the sheet size. Inside of here, you see this light blue line that's around basically all of these images. That's going to be the cut line. As we come in here, you can see I've made the step down power supply output and input sticker for servicing. Now, of course, these all have to be measured, so everything is to spec as far as for application. This will go over the heatsink on the top. You'll see once it's applied. And then over here, you can see that we have relay settings for Mach 3. Go to port and pins, go to output number 1, put the green check for port 1, pin 1. And this is allocated to the GX16 5-pin VFD interface connector. Its internal wiring diagram. Lead color is represented by the label's text. You can see that italic text represents the connections on the VFD's terminal block. So what does that mean? If I see italic, that simply means that for pin 1, it would be a blue lead for forward on the VFD, or FOR on the VFD. You can see analog, V+. This is not in italic, but this portion is. So VI on the VFD, meaning VI on the VFD's terminal blocks, would be actually allocated to pin number 2, and so on and so forth. And you can see the actual digital image of an HY VFD. So again, it's very, very basic and simple. So having these diagrams, guys, is so imperative for you guys to be able to service your system. I cannot tell you how beneficial these are. I've had clients tell me in the past they just love it. They're able to go in very quickly and do exactly what they need. Now, this image is probably the busiest of them all, but this will be mounted on the power supply inside the system. And you can see here, please read drive user's manual carefully to understand the parameters you're adjusting below. Incorrect settings can damage your drive motor. Please proceed with caution. Once again, we have the dip switch allocation. You can see the actual dip switch. We have micro step selection, gain selection, silent mode selection, and soft enable. When I told you that the SMCU is a very advanced drive, you can see by reading this just how advanced it really is. Here's our micro step selection. And you can see where you actually set the dip switches. And again, dip switch position is right here. Of course, on the dip switch, it does show you on the terminal block which way on is. And of course, it's in the down position. And then as we look at this, you can go from 200, which is 1-to-1 full step, all the way up to 1-256, which is 51,200 steps, which once again is absolutely ridiculous. To give you guys a baseline once again, if we were looking at a G540, it would be at 1/10 microstepping, which would equal 2,000 steps per revolution. So you could then go from there all the way up to here, which once again, really crazy. As far as resistors for your motors, the setting of the stepper motor current is performed using an external resistor marked with R set. Use quarter-watt resistors with a maximum tolerance of 5%. Replacing the R resistors should only be done when the stepper motor drive power supply is turned off. Parentheses represents a resistor range for optimal motor cooling with performance that must be tested by end users with their particular system. Now, what does that mean? This is interesting. Okay, if we look here, you can see for 3 amp motor, you got 6.8K, and then in parentheses it has 7.5K. And what that simply means is you can go within that range based on how your particular motor functions. Meaning, are you seeing a difference in the cooling of the motor if you want to tweak it to that level? They've done extensive testing to see within that range how motors perform, and not all are created equally. So if you don't need to create extra heat, do not. That's what these resistors are for. So you can check which range you want to go with and then make that adjustment based on what's required. Now, that being said, and I want to make sure you guys understand this, steppers are designed to get hot. They get hot because they're always drawing amps, unlike a typical DC motor. And why is that? That is because they naturally are pulling power and they are presenting holding torque to your system, so axes do not move until they're directed to. But that does not mean that when they are not receiving a step and direction signal for movement, they are not active. They are always active because they're providing, once again, holding torque. So keep that in mind. Unlike a regular DC motor, AC motor, unless they're on, that's when they're actually drawing power, drawing amps, and once again, functioning. Our motors are always functioning. So heat generation is a big thing. Now, the thing to keep in mind also is that as we read this, the MST109 microstep drive has built-in circuit that hardware monitors the current through the stepper's motor windings. If the current through the motor windings exceeds the set current value by more than 30%, the drive will stop working, i.e., overcurrent protection is activated. In this case, it is necessary to turn off the power supply to the drive and turn it on again, the power supply to the stepper motor drive. So basically what you're getting told here, very simple, is that the drive is smart enough to know, hey, something's wrong, and it's letting you know by actually going through and activating its overcurrent protection to, once again, stop everything so no damage is done, and it protects the system. Now, the chart below represents the drive's LED illumination. Does not light up, blinking slow, constantly lights, 2 short blinks, 3 short blinks. Stepper motor drive is not powered, stepper motor is powered up, disable mode, stepper motor is powered up, enable mode, overcurrent protection. So if this occurred and you had 2 short blinks, you'd have overcurrent detection, and therefore it lets the end user know exactly what's going on. It's all right here. Okay, so you could see how useful this is. Stepper motor inductance. Okay, now this is something seldom discussed, but this drive, again, you can go through and find out what gain level is best suited for your motors. So sometimes it's necessary to experimentally find the optimal choice of gain depending on the specific stepper motor. Mechanical transmission system. So every transmission is different, and therefore this drive allows you to find what gain level based on the motor's inductance best suits you. Now, if you're looking at a motor 1 millihenry to 4 millihenry, you would be looking at the lowest, and then it goes up from there. You've got, once again, middle for stepper motors with coil inductance from 4 millihenry to 8 millihenry. Higher for stepper motors with coil inductance from 8 to 12, and the highest for stepper motors with coil inductance greater than 12. Stepper motors with a relatively high nominal coil resistance, or stepper motors where the coils per phase are connected in series. So again, you've got a lot of information here to make sure you're going to get the most out of your system. And that is what I intended to do. I wanted to make it a one-stop for all of the settings that you would have to set up to make sure your system is basically ready to go, and of course customized to your particular transmission. Now, another thing you have is, and this is not really discussed here, but just to let you know, your standby on the motors, naturally the drive will turn itself off within a few seconds of the motors being stationary, and once again they're not moving, so it reduces current to provide holding torque, but once again not draw as much heat. So again, the drive is an intelligent drive system, and that is exactly what we're looking at with these newer level of drives. We want to make sure that everything is functioning, but of course it's not drawing heat continuously at the same amount that would be present when the robot is active. So now coming in and looking at this in great detail. Just so everyone is aware, I'm going to go downstairs and I'm going to show you the equipment that we're printing on live. You can see exactly what's happening. Now, this will be printed on an acrylic adhesive vinyl that I actually designed for these purposes. And then once that vinyl is printed, it is then laminated. It's very, very similar process to what you'd see in a base coat, clear coat paint job for my automotive guys out there. You have the base coat and then it's protected by the clear coat. Well, with graphics, you have the base coat, which is simply printing on the vinyl. And then after the vinyl has been printed on, we then seal the vinyl with 3M8518 glossy over laminate so that these graphics last indefinitely, essentially. Again, they're not going to be protected from abrasion or, scratches in the same sense that a car's paint job would. I mean, again, it's a coating. So the only difference with vinyl is it's a thicker coating than typical paint, but the process is exactly the same. The unfortunate part is that with vinyl, you cannot remove dust particles like you could in a paint job with wet sanding and all that neat stuff. Once it's sealed, that's it. So again, you guys can see this process. It's very, very similar to working with a router or a laser cutter or all of the other languages that support robotics. And I say that because this is a market that a lot of guys don't look at. And even if you're doing projects for clients dealing with woodworking and whatnot, I've done videos. I'm going to put I'll just show you right here. I'll put an insert of what I did actually using vinyl with a woodworking project to show what's possible when you mix languages. And when I say mix languages, I'm talking about using different software that deals with CNC robotics. And guys, just so everybody is aware, and we really don't think about it much, printers, inkjet, UV, whatever type of printer there is, you are essentially talking about a CNC robot. The only difference is in a basic form. Okay, it doesn't utilize G-code like what we are seeing, but it is a robot. You will hit print, it will produce the graphics, and what you do with those graphics are totally up to you. But it opens up a huge door for guys that see the benefit in using vinyl. And that was one of the reasons I did this, because like I said, when you see the diagram, or I should say the artwork on screen that I did dealing with woodworking, you will never be able to achieve that by hand. And it would offer the ability for end users to create furniture in a customized fashion that they would never see otherwise in a much more streamlined fashion. So thinking about that, seeing how this process is done, I think is beneficial. Once again, take your time, guys, and learn as many of these programming languages as possible. The more software you know, it's like learning different languages in society. You become more of use. You're able to do more. It opens up more beneficial areas for diversity as far as production. I can tell you right now, I use this equipment on a graphics business that I own as well, because the process is the same. And the thing about graphics that I truly love is how clean it is. It is absolutely clean. You can have the equipment in your house or in a separate room. It does not really do anything as far as make dust. It actually collects more dust. As long as you cover the equipment, you're fine. But think about what I'm saying. You have more diversity to create products. And I think a lot of guys, what they do is they kind of pigeonhole themselves and put themselves in a narrow niche market, and they don't look at opportunity as understanding diversity by owning different production robots. They stay in just one area of language. And when I say language, once again, I'm talking about software. So think about what I'm saying, and I'm going to show you guys now how we get to work making these units done.
Okay, guys, you can see we're in Vinyl Master once again. I've got the print all set up, and just to give you a breakdown of what you're looking at, this is essentially now having the registration marks added to the print. Registration marks are used so that the cutter will measure from these registration marks, scanning with its optical eye, and it measures then exactly where to cut. Now I have a Suma T75 series tangential head cutter. It's made in the Netherlands. It is the most premier vinyl cutter there is, in that it actually has a tangential head. And just for those guys out there that are curious, that simply means that the vinyl cutter's head actually rotates when it cuts. It's something really cool to see if you've never seen it, in that if you're doing curves or articulated bends in any way, instead of it typically just going over like most vinyl cutters and dragging a knife, its head is active, and therefore it actually cuts around the surface with an active head. And it's something really interesting to see. Once again, it's not a cheap cutter. It goes in excess of 5K, and the speed of this thing is insane. I have it turned way down. The accuracy is amazing in that it allows calibration. It's one of the few that you can calibrate X and Y axis so that you can get a super, super accurate cut well within a thousandth of an inch. So again, you can see here the preliminary. I can go then to view print only, where it takes the cut lines out, and I can also go to view cut only, where it's going to show where these graphics are going to be cut. Everything here is set. We'll hit view both, and I'm clicking on print. Now we're getting active. We've got the Epson P7000, and you can see it's got the vinyl loaded. Between this printer and this cutter, you're looking at well over 10K, and these pieces of equipment are both paid off, which I'm very happy to say. The beauty of this, guys, if you're looking at inkjet printing or you're looking at graphic production in general, is the fact that you are able to produce lots of money. Here's a client's order going out. And these are decals I made, and these are on clear. And once again, with the printer, you do not need to carry the 1980s vinyl where you have all different colors. You're able to produce anything at will. So again, when I say anything, even true fire flames. So when you think of all of those white spots to make these flames look real, all of this white would be removed, leaving a graphic known as a bleed cut, meaning there is no white vinyl showing, and therefore the flames appear to be printed on the model, or actually painted on the model. Okay. So really cool process. If you've never seen graphics produced, this is it being done live. So but I do think you guys then get the understanding of the gravity that it takes of the amount of equipment to do this. This is one of the areas I invested in early on in my business to make sure that my controllers had what so many didn't, and that is that it essentially had my support embedded on the controller, so clients are able to work on their own system with confidence and not actually having to come back and say, hey, what's this, what's that, how do I do this, how do I do that? They can service their own system. Let me see, I'll show them the... And just to show you some artwork that you can produce now, that's of course my buddy Al. And then over here, we've got an aviation photo that you can see, you can produce, and all we did there, you have a wood background, it's made to look weathered, and you then have the aircraft. So it gives you a lot of different options. Vinyl rack full of all printable vinyl, more printable vinyl, a chrome substrate that you can actually print on, turns your inks into more of an anodized finish. Those are really awesome. We sell a lot of that. But again, super clean, super quiet, and you can do this wherever you want, and it's just another language that many of you can add to your rapport as far as what you're able to do for diversity. Tell all of my clients that pay for consultations that are always talking to me about buying a bigger robot do not buy the biggest robot. And why I say that, you're better off buying multiple smaller robots, or better yet, diversify with different robots, and that opens up more doors for you to make money, pending, of course, you understand the programming languages that support them. And the beauty is, once you learn one language, most of the other languages are virtually the same. It's just understanding the robots you're working with. Graphics equipment is probably the most basic form of CNC robotics you'll get. Yes, it does not use G-code, but they've been around forever, and it will always be around forever because there'll always be a need for graphics. You will never be able to paint by hand what this machine can do without by hand. Now this substrate, just so everybody is aware, is just the base coat. And then of course, we have the 3M 8518 glossy overlaminate, and this will be the clear coat essentially that goes on. Now, give you an idea of the thickness. This is only 2/1000 thick. Has a backing on it. It's typically what's used on car wraps, so many of you guys understand what that is. Does have full UV protection, but the issue is getting the adhesive of this to be strong enough to bond with a vinyl that can produce, once again, outdoor resistance on top of maximum water resistance. And when I say maximum water resistance, not for this application per se, but this vinyl can be submerged, and I've done a test on video, it can be totally submerged with that laminate underwater for an excess of 24 hours with no bleeding on an inkjet printer, which is absolutely insane for those guys that understand what they're doing. You can see just how easy this is, and once again, you're hearing it live, so you can hear the noise that this machine produces. I cannot emphasize enough, if you're looking at getting into a way to make more money, especially my furniture guys, vinyl expands your market so greatly just due to the fact of the customization you can add. Especially when you incorporate finishes like epoxy coatings, where you can once again do an epoxy coating over the vinyl to seal it. You've got a graphic that lasts indefinitely. I've seen a lot of my clients use it for bar tops, all kinds of things, sports teams, you name it. Just about getting done now. When it's done, of course, I'll pull it out. Show you guys one other thing I want you to keep in mind, okay? Now, I'm showing you these prints, and I'm showing you the printing equipment we have here. And then over here, this is a MakerBot method, and this is in this area. And again, we're still unpacking a lot of stuff. There's my filament dryer, but this shows how easy it is today, and it should be opening up all of your minds to have multiple streams of income going simultaneously. Okay? You can actually have, I can have a print going here. As a matter of fact, I made some standoffs. That's out of ABS. You can see the filament dryer once again. And then coming over here, I can have both robots going simultaneously, and I'm making multiple streams of income simultaneously, okay? So it's pretty amazing what is possible when you factor in what we have with today's capabilities and understanding space constraints and robots for that space constraint. Too many guys overlook basics when it comes to making money. And the best way to make money And to do it in a fashion that's going to be the most profitable is to do it in a sense of where you're consistently earning. And you see it's wrapping up right now, and earning in a fashion that allows diversity. And there we go. Just load it. Okay. There's your clarity. Everything there, right to what you need. You can see there's a lot of information right here. You can see everything here. Now, of course, these were made to fit in those specific areas. Now, if I have a client that says, hey, Vin, can you give me extras? I want to put something on my shop table, or I want to put something right near my computer. We can do all that. See? And there you go. So when you see this laminated, I'll show you the cut process, and you've basically come into the factory of where we're doing it. And again, when you own the professional equipment, you own the languages that go with that equipment in the sense that you understand it enough to use it to produce work like this, regardless of what it is, whether it's a router, a mill, a plasma cutter, a laser cutter. This technology will make you the money you want. Okay, guys, we're getting ready right now to perform the cut on the graphics. You can see right here, we've got them loaded. You can see the digital screen. Hopefully it'll come in. Let's see. There we go. On the Suma, once again, you'll see the tangential head when it goes to cut. It's pretty interesting to watch go. Joanna's right now getting this set up so we can cut. Okay. Now it's scanning, once again, those registration marks and measuring. Now watch the head as it goes. You can see it's actually rotating. This is actually doing 2 passes, similar to what you would do with a router if you're cutting a thicker piece of substrate. Well, this is the same principle. Go down, let me see the head. Catch it, it's moving so fast, it's very difficult to see. Kind of similar to a sewing machine. That head, though, is so fine. It's amazing the detail again. We're done. That's it. So again, guys, you've seen how fast that was, and that's why I tell you guys, pay attention to every robot you can to learn different languages, and you can see exactly how this came out. Looks like glass as far as the mirror finish. It's now laminated, and next step will be applying these to our system. All right, guys, so now you've seen all the work to actually lead up to what we see here. And once again, we have all of our motor connections. Here is the details surrounding our motor connections, including step and direction signals for Mach 3, inputs for all of our switches. You can see all 4 of them right here. So we have 4, 3, 2, 1, X, Y, Z, and A. Over here, our VFD settings for our 5-pin. You can see that the mirrored connector right there matches the mirrored connector right here. It doesn't get any easier than this. Let's take the lid off. And now we can have a look at why these systems cost what they do. And you can see 24-volt terminal splitter right here. This way we know that the end user knows, of course, V plus red, V negative black. That's for the step-down power supply, which has its own graphic. You can see that right here. And then as we come over to our power supply right here, you can see all of the drive's information. Now, looking at this drive's information, you can see that we have all of our dip switches and everything to configure the drive right here. So it does not get, once again, any easier than that on the end user to configure their system and understand exactly what they're looking at. Now, resistors are now pre-installed for my motors. You can see them right here. And then coming over here, I wanted to discuss this because what I used was a PC mounting bracket for our DB25. Now, why did I do that? I did that because this cable, in order to make it so it fits appropriately where we didn't have to bundle up our ribbon cable, which again is not best practice because ribbon cables are susceptible to data corruption if they have a lot of sharp bends. You can see what I did. I just used the PC spring steel mounting bracket, made sure that it could clear the top of the enclosure, and it mounts everything absolutely beautiful and includes, of course, an EMI filter right here. So all of our signals then going into the drive are being filtered coming from the UC400. Okay? We take nothing for granted. Everything should be, once again, filtered or shielded. We then have our service labels, once again, for our fans, as end users understand, once again, that they should be cleaning their system on a regular basis. Number one, it makes them pay attention to it, and you'll find things that may pop up their ugly head over time. But servicing your system over a 2-week period, everybody should do. I don't care if it's, only being used an hour a day, 2 hours a day. You should be understanding exactly what you're working with. And that's the best way to do it. If you see something out of place or something just doesn't sound right, that's the easiest way to identify issues. Now, coming over here, you can see our input terminal splitter. And this is for a VSW signal for all of our inputs. So once again, input terminal splitter for our switches. And you can see the VSW red lead. And then we also have the black lead on the bottom, which is the ground for the switches. And you could just read the drive right here, and it tells you exactly what's connected. Switch 1, switch 2, switch 3, switch 4. Switch 5 is allocated to the E-stop. So very, very simple. And I want to clarify, I'm going to rotate the system now, because I don't even think I showed you this. Check this out. Forward and DCM are now on the motherboard. You can see it right there. There's a graphic allocating these two leads, so you know exactly how it's been configured. And guys, just so you know, look at the fit of that graphic on the board. And the reason I say that, let me take this camera real quick, is because when I told you in the previous portion of the video that Summa costs what it does, that's why it costs what it does. Because that right there came out absolutely perfect, and that's what you're paying for when it does its cuts. So again, you can see now exactly what we have, and I'm going to go to the front of the system because my clients love this. When they're setting it up, here is the graphic. Once again, x-axis step, direction, y-axis step, direction. Everything is here along with any review notes that they need, and they can set this system up in a matter of minutes and have motion. So let me just turn around again. Once again, you can see on this angle, and the ribbon cables once again come in. Everything is nice and smooth and comes over and is run as it should be, nice and clean. No sharp bends. You notice the ribbon cables are straight. And just so all of you know, your best friend when it comes to cables in general is heat. Applying heat, and when I say heat, reasonable heat, let me be explicit, no more than probably 150 to 200 degrees just to warm them, and it allows you to mold the cables. And it's the same principle I did here with the heat shrink. You can do that with your fans. You can do that with any cable you'd like, including silicone. Silicone, again, it can withstand a little more heat, so you can go up slightly, a couple degrees. But overall, heating is your best friend to allow the molding process. And you can see how we got the E-stop cable comes over our DB25 input, once again from our UC400, and you can see how nice and neat everything is done. There's no stress on anything. There's no contact between the circuit board and the ribbon cables. Everything was done with care so that the end user gets a system that they are paying for. So again, in the next video, is going to be system testing. We'll check out the motor speed. We'll see what we can achieve. She has now all been configured, so we're ready to go with the next video. This video got much longer because, again, I'm showing you all the base manufacturing as far as graphics, and that just covered the amount of time just to shoot that. Imagine how much time it takes me to design that, because again, this is a custom drive, so all of these settings are custom, let alone the graphics that I've already had in stock from previous systems. But anything dealing with drive information and setup, that's all done custom. So always keep that in mind. If you're not buying from me, but buying from another vendor, and they're actually taking that step, think about that. Think about what you have on this system now with all that information. You can service this beast in a minute. Right here, once again, we've got our motor allocation sticker. We do not just have the step and direction signals that are allocated on here for Mach 3, but of course, we have the GX16 5-pin wiring diagram, which once again correlates with all of our leads going into our drive. And you can see you have your X-axis on the sticker, X-axis here, Y-axis, Z-axis, and A-axis. And then, of course, if the end user needs to service this system, it's very simple. He knows exactly the way that the drive is wired. You have A+ for blue, A- for red, and then we have B+ for yellow and B- for black. Very, very simple. So again, guys, I hope that this portion of the video has been helpful. I hope that this really confirms when I say these are done with the utmost level of detail. Now you guys see it. I mean, you've got everything you need right here. And of course, I configure these in-house. I'll do all the testing, and then of course send you guys configuration tutorial videos if you don't know how to set up the UC400. And then basically go along. The system itself has all the diagrams, so you can basically set up whatever you'd like as far as the settings. So you do that at will. If you don't have a VFD, you know how to do it in the future. If you don't have switches, you'll know how to do that in the future, and everything is configured. Thank you all for your support. Take care.